Welcome back to the deep dive. So we've spent time charting the waters of ideation, defining architecture, and meticulously capturing every technical requirement. We moved from that abstract world of what should be built into the really concrete world of how the structure should stand.
Right.
But today, the whiteboards are wiped clean, planning docs are signed off, and, well, the glove's coming off. It's time for execution. We're moving from planning to the keyboard.
That's the critical pivot point, isn't it? The requirements have been formalized into these discrete, measurable technical tasks.
Right.
And the team has its first block of work, the first time box. So our mission in this deep dive is to really shortcut your understanding of the essential infrastructure that manages this whole process.
Yeah, we need to see how the code is organized, how it's protected from, catastrophic failure, and how every single change links back directly to the original user request.
Exactly.
We are diving deep into the developer workflow and that sort of invisible engine that powers it all.
Version management systems. But before a single line of code is even written, you have the organization of the team. That dictates the whole flow.
Okay, so developers are grouped into teams. The project manager, they're holding the schedule, the overall vision, but the day-to-day task allocation, that's often a team lead or a scrum master, right?
Yes, they're the tactical map makers. And their first job is ensuring those high-level requirements, which sounds so simple on paper, get translated into these atomic executable tasks.
Okay, so let's make this, really concrete. Our sources use a great example. A high-level requirement that says something like, provide login screen for user, requesting both username and password.
Right.
To the end user, that sounds like one interaction, one screen.
But for the developer, that's a whole different world. That one line it's just the tip of the iceberg. What the development team actually gets is a whole stack of associated technical specs.
So they don't just know what to build, they know all the nuts and bolts.
Exactly. They need to know the database being used for authentication, the precise schema definition of the user table in that database, and even what specific stored procedure is called behind the scenes to authenticate that user.
Wow. So it's the difference between ordering a bespoke piece of furniture and handing the craftsman the exact blueprints, the precise type of wood, the required glue, everything down to the part number for every single screw.
That's a perfect analogy. The granularity ensures consistency and speed. Developers aren't left guessing, which database to use or how to structure a table.
Because those decisions were already locked down back in the planning phase.
They were. And once they know the specific rights the user must possess, are they an admin, a basic viewer, they can write the code to retrieve that data efficiently.
And these incredibly detailed requirements are then parceled out to specific developers to start the work for that first-time box.
They've got their marching orders. But even before they type that first line of code, they are relying so heavily on the work of others.
And that's the fundamental efficiency principle of modern development, right? Code reuse. Never, ever start from a completely empty slate.
Never. Even if you're building something totally groundbreaking, you are, as they say, standing on the shoulders of giants.
The sources really highlight this reliance on libraries of code. Why is that so crucial? I mean, isn't there a risk in using code you didn't write yourself?
Well, it's a calculated trade-off. Think about it. Why would you spend 3 weeks writing, testing, and debugging a complex algorithm for, say, secure password hashing?
Right.
When a globally recognized open source library already exists, it's been vetted by thousands of engineers, and it's known to be robust. That time is just better spent on the unique features of your application.
So the developer might pull in an external library for handling the visual front end, like a big framework like React, or maybe an internal library the company wrote 5 years ago for handling payment processing.
Exactly. This reliance on reusable components, both proprietary and open source, is what makes modern project timelines even feasible. It accelerates development by orders of magnitude.
But I guess the risk is still there.
Oh, absolutely. You're right to mention it. Using external code means developers and the architecture team have to be incredibly disciplined in vetting these libraries for security vulnerabilities, ensuring they're actively maintained, and making sure they fit into the architecture we already defined. You're basically trading the time cost of writing it yourself for the diligence cost of integrating and securing it.
Okay, so they've pulled the necessary libraries, the coding begins, the work is happening on a developer's desktop or their laptop. And right there, that's where the first huge high-stakes problem comes up, isn't it?
It really is. The problem of, Local storage, it's a single point of failure.
A single point of failure.
If that developer keeps the only copy of their new login code on their machine, that single laptop becomes the most dangerous bottleneck in the whole project.
A spilled coffee, a failed hard drive.
Or even just an accidental deletion. And you've set the project back for weeks. In a team environment, that risk is completely unacceptable.
So we need the ultimate fail-safe, the central repository that protects everyone's work. And that, of course, is the version management system, or VMS.
You can think of it as the ultimate safety deposit box for code. It's essentially a code library that tracks every single action taken.
Developers check out existing code, they update it, and they check it back in.
We call that committing the code, and this system is just the heartbeat of continuity and safety for the project.
Now, in the old days, these VMS systems were often centralized. And it was like a textbook in a library, right? If I checked out the file for the login screen, you were completely locked out until I checked it back in.
Which was a collaboration nightmare. It was an absolute disaster for large teams. It caused bottlenecks, frustration, developers sitting around idle, waiting for simple files.
Yeah, I can imagine.
This is why the rise of the distributed VMS became such a monumental shift, and why one system in particular just completely dominates today.
And the origin story of GIT is one of those fantastic, sort of surprising facts.
It really is. GIT was initially developed by Linus Torvalds,
The creator of the Linux kernel.
the very same. I mean, just think about the scale of collaboration he needed to manage. Thousands of independent contributors all over the globe working on the same massive operating system. He needed a system built for trust and autonomy, not for bottlenecks.
So what makes a distributed system so different from those older centralized models? What does that actually mean for the individual developer?
Well, it means it relies on repositories, or repos, which exist in two primary places. This gives you layers of safety and flexibility. You have the remote repository, that's the definitive shared source of truth, hosted offsite or on a central server.
Okay, the master copy.
Exactly, the one everyone collaborates against. But, and this is the crucial part, every developer also has a local repository on their own machine.
So the key insight here isn't just that there are two repos, but that having that local copy gives me complete autonomy.
Complete autonomy. The power of distribution means that when you check out the code to start working, you don't just get the latest version, you get a complete historical copy of the entire project.
Wow.
So if the network goes down or the remote server crashes for a bit, you are not dead in the water. You can keep working, tracking your changes locally, even rolling back mistakes. It fundamentally changes the relationship between you and the network. You aren't dependent on constant connectivity anymore. You have the full history right there on your machine.
And it's more than just a backup, right? I mean, that's the baseline. The real power here, it seems to me, is the history, the complete narrative of the project.
A complete autobiography of the code. That's a great way to put it. The VMS holds copies of every single revision ever made on every file. That's its first massive strength.
Yeah.
The ability to turn back time.
So if a bug gets introduced, that breaks something.
You don't have to manually hunt through lines of code. You can instantly revert that file back to its state from 5 days ago or 6 months ago. You can surgically remove mistakes without affecting any of the surrounding code.
Okay, and the second strength is accountability, the metadata. It tracks the human story behind the code. Why is tracking the who and when so important?
Because software development is a team sport, and teams change over time. When a developer commits their change checks, their files back in, the system records that crucial metadata, who made the change, the precise time it was done, and critically, the reason or comment they provided.
That comment is the narrative.
It is the narrative.
So let's make that tangible. Say a bug is found on the live site 2 years from now. That metadata, it's not just a record, it's the trail of breadcrumbs you use to find the exact moment the error was introduced.
Precisely. If we trace a bug back to a specific file, say userauthentication.py, the VMS history tells us that developer X changed this file on October 12th at 4:00 p.m.
And the reason?
Their reason was refactored input validation to increase security for requirement, #401. That Y saves the current team weeks of work because they immediately know the context and the original intent.
And this is the magic intersection. This is where the version management system and the requirements management system we talked about in our planning deep dive, where they have to talk to each other.
They absolutely must. A properly configured system links those changed files directly to the reference number in the RMS. This is how project managers, auditors, non-technical stakeholders, how they all get visibility.
So they can look up requirement #401 or provide login screen and instantly see every single file, front-end, back-end database that was modified to deliver that one feature.
Yep, which is critical because a single requirement often touches a dozen or more files. Without the VMS linking them, the project manager would have no idea what work was actually done.
So once the code is committed, stored, tested, and linked back to the RMS.
The requirements management system is used to update the status. It marks that requirement as having completed development. It transitions from a work in progress to a build candidate, ready to move on.
We talked about how this whole distributed system, avoids that old problem of one person checking out a file and locking everyone else out. But what happens when two people are working on the same file at the same time? I mean, that sounds like you're just asking for chaos.
It is the ultimate test of the system, and modern VMS handles it, well, beautifully, through what's called the merge process. So developer A checks out the login screen file. Developer B checks out the exact same file. Both work independently.
Okay, so when developer A commits their changes back to the remote repository, and then developer B tries to commit theirs, what happens? The system just explodes.
No, the VMS attempts to perform an automatic merge. If developer A changed a comment on line 5 and developer B changed the functionality way down on line 50, the VMS is smart enough to combine those changes seamlessly into a single revision with both updates. This happens millions of times a day.
But inevitably, they're going to step on each other's toes. They both change the same line of code, but for different, maybe conflicting reasons.
And that's the moment of the merge conflict. The VMS stops. It flags the issue, it alerts the developers involved, and it refuses to proceed automatically because it can't intelligently determine whose change should win.
So it needs a human referee.
It requires human cooperation. Often it's the two developers sitting down together, manually amending the code to make sure the final merged file has the intended combined functionality.
I imagine the person who caused the conflict probably owes the other developer a coffee.
It's often the price of doing business. But the point is, the VMS acts as that impartial referee, forcing the collaboration at the exact moment it's needed, rather than letting a silent conflict break the entire system later.
Okay, so before this merged code, even the automatically merged stuff gets committed to the shared remote repository, there's one last non-negotiable quality gate that's all on the individual developer.
Yes. Unit testing. This is the developer's personal responsibility. It's standard procedure. They have to ensure that the specific unit of code they wrote works exactly as required.
And this usually involves setting up a small test environment on their own computer or a local server.
It does. And the golden rule is you do this before you check it in.
Right.
Absolutely. Checking in untested code is, well, it's development heresy. It instantly destabilizes the shared repository, it breaks the work for every other developer who pulls that code, and it just undermines the reliability of the entire time box.
So that commitment to the VMS is a signal to the whole team. This works. This is stable.
Exactly. And as each developer finishes their tasks, their unit tests pass, those requirement entries in the RMS get marked as completed, preparing for the next step.
All right, so let's sort of pull back for a second and look at what we've covered.
Yeah, it's a big journey.
We went from this high-level vision all the way down to individual execution. We've seen how developers leverage these massive pools of existing code and how the distributed version management system like GIT acts as this ultimate collaborative engine.
Right. It manages risk through redundancy, enables all this concurrent work, and creates an indispensable historical record. It's the infrastructure that guarantees the project moves forward in an orderly, traceable way.
So now that development for this time box is complete, the requirements are updated, the code is safe in the VMS, the immediate next phase begins.
Transforming those thousands of completed code files into a single, cohesive, working product.
That's where we move into automation. We need a system that periodically, pulls the VMS, pulls those stable files, and automatically builds and compiles the entire project.
And that is the domain of the automated build management system, which will be our next deep dive. But as a final thought, building on everything we discussed today, consider this. The VMS provides the structural integrity, the who and the when, but its power relies entirely on the human narrative.
The comment.
If a developer skips that descriptive comment or just writes fixed bug instead of detailing which requirement they addressed and why, that entire historical strength is compromised.
So the reliability of, say, a $10 million project years down the line can hinge on whether a tired developer took an extra 30 seconds to type a clear, descriptive reason or comment during their 5:00 p.m. commit.
Precisely. The technical system is flawless, but the integrity of the project's history depends entirely on that one moment of human discipline. You have to think about the story you're leaving behind for the team that comes after you.
A fascinating insight into the blend of human and machine required to build modern software. Thank you for joining us on this deep dive into the developer workflow. We'll catch you next time as we jump headfirst into build management.
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.